In this video, I'm going to talk about logarithmic properties. Before I got into the actual properties, I wanted to refresh some essential nomenclature. So a logarithm is composed of a subscript and a superscript, and let's say the subscript is usually 10, so I'm going to write 10 here, and let's just say that the superscript is x. So the way you represent that, to abbreviate it, is just you write log x. So when you see log x, that means it's logarithm base 10 of x, meaning that the only thing you write is the superscript, but you will know that the subscript is 10. However, when you see something like ln, that means it's natural logarithm of something. This means that it's log base e, let's say ln of x, and the superscript is just x. So log x has a base of 10 and ln x has a base of e, which is a constant. So now let's get into the actual properties. The first property I want to talk about is the logarithm of the same number. So that means that the subscript is equal to the superscript. So log, let's say a of a, that will be always equal to 1. Let's say an example, when you see log 10, that will be equal to 1. Because as you may remember, as I just talked, log of 10 is going to have a base of 10 and just a subscript of 10 and a superscript of 10. In the same way, ln of e will be also equal to 1. So when the subscript is equal to the superscript, the value will be equal to 1. So that's rule number 1. Rule number 2, a logarithm of 1 will always be 0. It doesn't matter which subscript it has, the logarithm of 1 will always be 0. So it can be ln of 1, it will be 0 too. So whenever the superscript is 1, the value will be 0. Rule number 3, the logarithm of a multiplication will be the sum of the logarithms of each of the factors. So let's say, let me change the color, the logarithm of a times b will be equal to the logarithm of a plus the logarithm of b. Let me make it a little smaller. So whenever you have a multiplication, you will separate the logarithms into two parts. So first it will go to the logarithm of the first factor, and so like this, and then it will separate to the other factor. So you will have two different logarithms. The fourth rule is the opposite of the third rule. So in this case, it's a division instead of a multiplication, and it will be a subtraction instead of a sum. So let's say logarithm, let me make it smaller from the beginning. Logarithm of a over b is going to be equal to the logarithm of a minus the logarithm of b. So rule 3 and 4 are easy to remember because they're just the opposite of each other. Rule 5, the fifth rule has to do with powers. So let's say the logarithm of a to the power of x will be equal to x times the logarithm of a. So all you're doing is multiplying the power of this variable to the whole logarithm. So you see how it went from the power to just a product. Now let's go to the sixth rule. This property or rule just states that you can separate a logarithm. So let me show you. If you have the logarithm of, let's say, base a of b, so that means that the subscript is a and the subscript is x. A could be 10 or whatever. You can separate that logarithm into two different logarithms. That means that will separate into the logarithm of b over the logarithm of a. And these logarithms, these two, have a base 10, so their subscript is 10. Let me make it clear, because I use the opposite color. Subscript is 10. So an example makes it easier. Let's say we have the logarithm with base, let's say 3 of 5. I'm just making up numbers, so that'll be equal to the logarithm of 5 over the logarithm of 3. Or, in other words, it's logarithm base 10 of 5 over logarithm base 10 of 3. You may be wondering what happens to something like this. Log of 8, let's say. I mean, can you separate it? Can you separate it using the same rule? Yeah, you can, but let's see what happens. So this means that the subscript in this case is 10, right? So you can separate this into log 10 of 8 and log 10 of 10. Now if you go back to rule number 1, log a of a is going to be equal to 1. So this is just 1. And it will just go back to log 8 or log 10 of 8. Let's go to rule number 7 now. That's a horrible 7. Sorry. And this goes back to one of the previous rules we talked about. I think it was rule number 5, the one on the power of. So when you have, let's say, log 10 to the x, that will be equal to x, only x. That's because, as you may remember from rule number 5, when you separate this, you will put this the factor or the power of there and multiply it by the logarithm. That will just be log 10, and this is log 10 out of 10. Rule number 1 again, that's 1. So you only get the x. And to bring back the natural logarithm, let's give an example with that. ln of e to let's say the power of 2, just to give a number, will be 2. Just using the same rule used here. Now let's go to rule number 8. This one is also called the reciprocal property. That just says that, let's go with the same as we've used, log base a of b is going to be equal to 1 over the inverse of that. So log b base b of a. So you're just changing the superscript and the subscript. And finally, rule number 9 says, let's say we have a to the power of a logarithm that's base a over x is going to be of x, sorry, is going to be equal to x. So the same way, let's say 10 is our a. 10 to the power of logarithm, sorry, I forgot the O here, of x, that says again that the subscript is 10, is going to be equal to x. And using the natural logarithm again, e to the ln x is going to be equal to x. And well, those are the 9 rules or properties of logarithms. It's good to keep them in mind for calculus, as they can make your life easier when solving a derivative or integral. And as always, if you like the video, if you found the video helpful, like it and share it with your friends.